Hello everyone. In this video tutorial, I'm going to show you how to do a stress strain analysis in ABAQUS software. Stress strain analysis quite important for mechanical engineering and also aerospace, even for structural engineering too. Now here is an example which we conduct to see how the stress is distributed across an element. Now we want to do a very simple model, and the simple model is a plate with a hole the inside. I want to change the my graphic display, and I'm going to use white, and you can come the same area to it. And now in the first part we'll start by creating the part, and I'm gonna call it plate. In a plate, using a 3D shell element, the unit I use millimeter, so I want to use the length is about 1 meter, 100 millimeter, 1000 millimeter, and the height is about 800 or 700, at least 700. So now the thickness is 2 millimeter, 10 millimeter. So we created a solid element, and we want to create an extrusion inside of this plate. We can select this plane and one of the edges, and here it is. So we want to create a circle inside of this plate. So the circle radius is 100 millimeter. Now we're gonna extrude it, and you can see like this. The next, we're gonna go to property, and we want to create a properties called steel, and we want to give the elastic modulus 200,000 and 0.3. For the mechanical plasticity, I want to give elastic 260, 0, and we want to use a bilinear. So the ultimate strength is 420 and 0.20 the ultimate strength. Now next, we want to create a section called solid. We define the material and assign it. Next, we go to assembly and input this plate to here. I want to do one more thing, and taking this single point to be in 0, 0. Now we can go to here and we can see it. Assembly is finished. We want to conduct a nonlinear standard static analysis. Nonlinear static. The time period is 1 second, 1 second, and I'm going to, we can activate or check the nonlinear geometry, giving 1000 and 0.1 second, and it's b to 15, so maximum is 1. Next, we can go to the interaction. So we don't need interaction. We go to load, and the first we want to apply a boundary condition in this direction. The boundary condition can be fixed this edge this edge, we want to fix it. Now you can see. So the second edge is we want to apply some force, some pressure. Let's go here and in static, and I'm going to apply some force. So here is we should calculate how much pressure we should apply. Let's suppose we want to apply uh, 1 kilonewton. So 1 kilonewton is equal 1000 newton. So the area is about 800 times to 10. Now this is the area and this is the force. Now here is, I should say, equal 8800 times 10, which is 8000. Now here is the pressure we want to apply in that edges or in that surface. Now it's equal that force divided by this area. So now the amount of pressure is 0.125. We go to here and select pressure in this surface. Now you can see here is the magnitude of the pressure. How much is if we want to apply a negative, so it's stretching, is 0.125. Now you can see we got. So the next thing is we want to go to meshing. One more thing, sometimes we should usually they have a lateral support. There is also support. We can create a lateral support as well. I can call it U3. Selecting displacement, and we can select these edges, and just U3. This is very important, otherwise the structure is not stable, we cannot get the good result. So in the practical we don't have such kind of element to load like this, but instead we have a like box or some sort of like in case we have some other support in the lateral. Now what we're gonna do is to go to mesh and create a mesh. Now we can use this mesh and giving a this 25. We can see that mesh is swept, and we can create a mesh. So this is the meshing area. Looks like near to the all is watershed and more. So in case when we are stretching the load, the most stress will be in this area. Now it's finished. We're gonna go to job and submit the job. We called stress strain. Submit. We're gonna monitor if there is any error. We'll fix. Otherwise, we can lead to finish the analysis, and then we will check the result. So it's started and it's completed the analysis process, and it will take some time to finish. That load is actually gradually will increase. So we if in case we suddenly apply that will have some difference. Yeah, it's completed. It's 1 second, and we can go to see the result, and we can go to the 2D, and this is the stress strain concentration. So now we can see the maximum stress is very less. In case if we go back to the load and apply some let's we want this load should be times by 5 times or 10 times or even 20 times. So what we're gonna get, we're gonna submit again. Actually, by applying more load, we want to see more deformation and more stress concentration, and especially we want to the stress should reach to ultimate stress and strain. This is, yes, again it's finished, and we can go to result, and this time and now it's also small amounts. Now, okay, what we're gonna do is we want to create some graph and see how this behave. In case if I go to the remove the measure and edges, and you can see the concentration, it looks like a watershed. So this is least and this area is least when it's stretching these two area, because the thickness of this, the length of this area is least, so the most stress is concentrated, but this is larger, so this is least. Now we want to go to the output, create output, and we want to ask integrated point, selecting one mesh stress, or you can use another stress as well, and I want to get the uh, linear elastic. Now I'm going to select one element in here and I'm going to plot it. So it's still in the linear area. So this is the stress and this is the if I go back to create a combine, and this is combine, the strain should be in a x and the stress should be in the y. Now I can call stress strain. Now I can plot this one, plot, and this is the graph. So what we got is here is the we didn't reach until the yield part. So because the load is quantity is very less, we can increase more. So I will extend again and go to back to load, and this time I want to make this one by 1000. So I increase this load by 1000 is 205 Newton per square millimeter. We're gonna job and we want to submit it again. Now this also started, and it take more increment to finish because there is a very large deformation, so it need more increment. So it's called too many attempts made for this. So the load is increased significantly, so the deformation reached to the maximum. We can see now the result. And now you can see here is the deformation will reach to maximum, and here is 420. Now we can go back again here and create from ODB the same element we already selected, and this area, plot, and here is the strain stress curve. Now we're gonna go to back here to create combine. The strain is in the x and stress is in the y, called stress strain curve. Now you can this is two, one is from the first one and the second is from the other one. Now here is the graph which we go up and then again increasing to ultimate and then reaching again. So this is the graph, and the second graph is very small, and it can see in case if I go to here. Oh, it's actually inside in this very small here, because if I go to change this thickness of that one, and you can see here is. Okay, now it's finished. We can go to see again some here is how it changed. You also can find other parameters, other factors, and you can see them, measure them. Okay, now it's finished, the end of the tutorial, and see you next time.